In this video, we're going to be looking at how to solve absolute value inequalities. Now, this is going to tie together absolute value equations and the review we did on compound inequalities. Now, when you're solving an absolute value inequality, the steps for solving it are very much like the steps for solving an absolute value equation. Your first step is to isolate your absolute value on one side of the problem. Then you create two cases. In your first case, you don't change anything. Change nothing. For your second case, use the acronym KISS to help you remember what you're doing. KI is keep it. This means you keep the part in the absolute value the same. You do not change anything in the absolute value. The first S is switch, meaning you switch the direction of your inequality from less than to greater than, or the other way around. The second S also stands for switch, but in this case it means you switch the sign of the other side. After you have your two cases, you're going to solve each inequality. After you have your inequality answers, you're going to graph your answer on a number line and then write your answer in interval notation. So let's look at our first example. Step one is to isolate the absolute value, but if I look at this side of the equation, there is nothing on this side outside of the absolute value. Therefore, it's already isolated. This means we move to the second step, which is to create two cases. In your first case, remember you changed nothing. So our first case will be 7 minus 4n less than or equal to 27. In your second case, again, keep it, keep your absolute value, switch the inequality, and switch the sign on the other side. KISS. Keep it, switch, switch. Now that we have our two cases, we're going to solve each inequality. So the first step in solving this one is to subtract 7, which gives me negative 4n less than or equal to 20. Then I divide by negative 4, and be careful here. Anytime you multiply or divide by a negative number, you must flip the inequality. So this is now greater than or equal to negative 5. Once you have your first case solved, you go over to the next case and solve it pretty much the same way. You just end up with different numbers. Subtract 7, which gives me negative 4n greater than or equal to negative 34. Then you divide both sides by negative 4. And remember that you flip the inequality because you divided by a negative. So this is now less than or equal to, let's see, that is 8.5. So let's put this on a number line, and I don't have a lot of room here, so I'm just going to do this. Whenever I go to put these on a number line, you're going to have a closed dot at both of these locations because it's or equal to. So I have a closed dot at 5 and 8.5. Greater than or equal to negative 5 means it goes to the right. Less than or equal to 8.5 means that part goes left. So they meet in the middle. This is a compound inequality. All absolute value inequalities are compound inequalities. This is the AND type. So these are my inequalities. That's part of the answer. This is my number line, which is also part of my answer. The last thing is to write this in interval notation. Now, interval notation, remember, is your smallest to your biggest. Where does it start? Where does it end? This one starts at -5, ends at 8.5. Both of these dots are closed, therefore both sides are enclosed with brackets. If you need to review the interval notation for and or type inequalities, check out the review on inequalities video. In my next example, my inequality is not, my absolute value is not isolated in this inequality. If I look at this side, I have this 4 on the bottom. I don't want that. So it's divided by 4. To undo the division, I will multiply both sides by 4. This gives me the absolute value of x minus 1. Remember, multiplying by 4 here does nothing except cancel this denominator out. On the other side, I have 8. And remember, we multiplied by a positive, so we did not have to flip the sign. Now that my absolute value is isolated, my next step is to create 2 cases. Case 1, change nothing. X minus 1 greater than or equal to 8. Case 2, kiss. Keep it, switch, switch. So to solve these inequalities, all I have to do is add 1. In the first case, that gives me x greater than or equal to 9. In the second case, that gives me x less than or equal to -7. Now, these are my inequality part. That's the inequality part of my answer. Now, on my number line, again, I'm just going to put my 2 numbers. I'm not going to fill in everything in between. But this one, just like the previous one, is going to have closed dots at these locations because it's or equal to. So a closed dot at -7, and 9. Greater than or equal to 9 means that one goes to the right. Less than or equal to -7 means that one goes to the left. There's my number line. Now I have to do the interval notation. This is an OR type inequality. On the OR types, just take it one piece at a time. So this section, where does it start? Where does it end? Well, this arrow means it goes forever. So we say it starts in negative infinity. And because you can't reach infinity, you use a parentheses with that. This section ends at -7. It's a closed dot. It can actually get to -7, so it's a bracket. To join this first piece with the second piece, you use this symbol here. It looks like a U. This symbol means OR. Then we look at our second piece. Where does this start? Where does it end? Well, it starts at 9, and we use a bracket for it because the dot is closed. And it continues right forever, so it goes to infinity. Parentheses with infinity. We're going to do a few more examples. One more example where there's only one step in isolating, and a couple of examples where there's multiple steps. Now this one I wanted to do because a lot of my students, when they see a -10 in front of the absolute value, they try to move it by adding, which is wrong. Because what you have is -10 multiplied by the absolute value of this expression. So we're undoing multiplication here, which means you're going to have to divide. We divide both sides by -10. Now since we're dividing, this means that we're going to have to flip the inequality. So we have the absolute value of 2r minus 1 is greater than or equal to 6. Now the absolute value expression is isolated. I'm going to make my two cases, which are 2r minus 1 greater than or equal to 6. You don't change anything for your first case. For your second case, kiss. Keep it, switch, switch. Keep your absolute value, switch your inequality, switch your sign. Once you have your two cases, you solve. So I'll start by adding 1 to both sides, which gives me 2r greater than or equal to 7. Then divide by 2 to get r greater than or equal to 3.5. Here, add 1 to both sides, which gives me 2r less than or equal to negative 5. Divide by 2 to get r less than or equal to negative 2.5. When you go to put this on a number line, and again, I'm cheating a little bit on my number line. I'm just going to do the two numbers in our inequalities. When you go to do your number line, again, I have closed dots again. You know what? I had nothing but closed dots. I'm going to change this one up a little bit. It's still going to be less than, but I'm just going to have it not equal to. Okay, back to this one. Where was I? Oh yes, the dots. Or equal to, again, means closed dots. Greater than 3.5 means that one's going to the right. Less than 2.5 means that one's going to the left. So this is another OR type. I have my inequality, I have my number line, now I just need the interval notation. So starting with this section, it starts in negative infinity. Doesn't really have a starting point, so we say it starts at negative infinity. This section ends at negative 2.5. Bracket, because it's closed. Or we have the next section. Bracket, because it's closed at 3.5, and it goes right forever to infinity. Close with the parentheses. So there is my interval notation for this solution. Okay. In my next example, there's multiple steps we're going to have to take to isolate the absolute value. When I have the numbers in front like this, I get students a lot of the time they'll take the wrong first step. Sometimes they'll do -1 minus 4 and get -5. Sometimes they'll move the -4 first and then the -1. There's a variety of different ways I've seen students make mistakes. The correct first step is to add 1 to both sides. It's kind of like this. If I had, just do an example here. If it was -1 minus 4x equals 21, you would start by adding 1 and then dividing by -4. It is the same thing here. I'm going to start by adding 1 to both sides. This gives me -4 times the absolute value of x plus 9 less than -20. Then I'm dividing off the -4, which gives me absolute value of x plus 9 greater than 5. Remember that when you divide by a negative, you must flip the inequality. So my two cases. Case 1, change nothing. X plus 9 greater than 5. Case 2, kiss. Keep it, switch, switch. Now that I have the two cases, you solve. Subtract 9 from both sides. get x greater than -4, subtract 9 on the next case to get x less than -14. So these are my solution expressed as inequalities. Let's graph it on a number line. And again, and that would be 14, that would be 4. There we go. I'm just doing a very shorthand number line. I'm not going to put everything in between them. On this one, I changed it to where it's just less than, so I'm going to put open circles for these two. Now, greater than -4 is going to the right, less than -14 is going to the left. So this is another OR type. I have way too many OR types. I'm probably going to change my next one too. Okay, I'll do that in a minute. For now, let's finish this problem. Interval notation, that's where we're at. So interval notation, it's starting at -infinity. Parentheses for that. This section ends at -14. Open circle means I close with the parentheses. Or, next section starts at -4 with the parentheses because it's open, and it goes forever to infinity. Close of the parentheses. Now, I'm going to change this next one. I'm going to make this greater than. Okay. So, in this example, it's very similar to the last one. It's just the add or subtract number is behind rather than in front. For some reason, I get more mistakes when the number is in front, like in the previous example. But your first step will be to add 9. Okay. So this gives us 4 times the absolute value of 9 minus 3n greater than, that'd be 84. Then you divide by 4, because this is 4 times the absolute value. You're undoing multiplication. This cancels the 4 out over here, leaving us with the absolute value of 9 minus 3n is greater than 21. So 2 cases. 9 minus 3n greater than 21. Change nothing for your first case. Second case, kiss. Keep it. Switch. Switch. So to solve this, you first start by subtracting 9 from both sides, giving us negative 3n greater than, oh my goodness, my brain just froze, 12. Then you divide by negative 3. Be careful, you're dividing by a negative, which means you flip the inequality, so it's now less than, and you get negative 4, n less than negative 4. Over here, same process. Subtract 9, which gives us negative 3n is less than negative 30. Divide by negative 3 to get n greater than 10. Again, don't forget to flip the sign when dividing or multiplying by a negative. Alright, there's my inequalities. Now let's put it on a number line. And again, I'm just doing a very shorthand number line without everything in between. This still ended up as an or. I should have left it the other way. Oh well. Open circles. Okay. -4. It's less than -4, so that one goes left. Greater than 10, that one goes right. So, parentheses, negative infinity, comma, -4, close parentheses, or parentheses 10, comma, infinity, close with parentheses. I really messed that up in my head. I really thought that was going to be an and. Oh well. Just all of these ended up being or types. Just remember, the and type, it's much simpler on the interval notation. It's just going to be two numbers. So, you know what? I'm going to do another very, very quick one just to show you. Let's see. Alright, let's try this one. 2v, oopsie. 2v minus 3 less than or equal to 19. Just to show you one more, and I'm almost positive this one actually does come out to be an and. So 2v minus 3 less than or equal to 19. 2v minus 3 greater than or equal to negative 19. Okay. Add 3 to both sides, and I get 2v less than or equal to 22. Divide by 2, I get v less than or equal to 11. Over here, add 3 to both sides to get 2v greater than or equal to negative 16. Divide by 2 to get v greater than or equal to negative 8. So this one, close dots, because it's equal to, less than 11, but greater than negative 8, makes them meet in the middle. Interval notation, where it starts and where it ends, that's what's going to go inside of it. Closed dots means brackets. If they were open dots, let me just give you another quick example. So 6 and 21. Let's say you had an answer where the number line ended up being this. Interval notation would just be 6, 21, but with parentheses around it instead of brackets. Okay. If you need more help on the interval notation, whether it's the and or the or type, again, my reviewing inequalities video has more detail on that.